Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. Make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have x to the power of 3 minus 27 is equal to 0. Now, I'm trying to find the value of x here. So, for my solution, I first start with x to the power of 3 minus 27 is equal to 0. Now, 27, this is the same thing as 3 to the power of 3. So now if I substitute in 3 to the power of 3 for 27, I get x to the power of 3 minus 3 to the power of 3 is equal to 0. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, a is equal to x and b is equal to 3. So now I have x minus 3 times x squared plus 3x plus 3 squared. That's equal to x minus 3 times x squared plus 3x plus 3 squared, which is 9. And remember, this is equal to 0. So now this gives me 2 equations. I have x minus 3 is equal to 0, and I also have x squared plus 3x plus 9 is equal to 0. So for x minus 3 equals 0, all I have to do is add 3 on both sides. These two cancel out, and I'm left with x is equal to 3. So this is one solution. Now for x squared plus 3x plus 9 equals 0, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now in this case, a is equal to 1, b is equal to 3, and c is equal to 9. So now I have x is equal to negative b, so negative 3, plus or minus the square root of b squared, so 3 squared, minus 4 times a, which is 1, times c, which is 9, all over 2a, so 2 times 1. So now I have x equal to negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times 1 is 4, 4 times 9 is 36, all over 2 times 1, which is 2. And now I have x equal to negative 3 plus or minus the square root of 9 minus 36, that's equal to negative 27 over 2. And now negative 27, the square root of negative 27, I can rewrite as the square root of 27 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1, this is actually equal to the imaginary number I. So now, if I replace I with the square root of 27, or sorry, the square root of negative 1, I get negative 3 plus or minus the square root of 27, I over 2. So these are 2 other solutions to this problem. So now my first solution, this is 3. My second solution, this is negative 3 plus the square root of 27i over 2. And my third solution is negative 3 minus the square root of 27i over 2. So these are my 3 solutions to this problem. Alright, so I have 2 to the power of x is equal to 5. Now I want to find the value of x. So for my solution, I first start with 2 to the power of x is equal to 5. Now I'm actually going to take the log on both sides. So now I have log 2 to the power of x is equal to log 5. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this is going to equal b times log a. And this property is actually so important because, as you can see, right now we have 2 to the power of x is equal to 5. And x here, this is an exponent. And it's going to be really hard to find the value of x without it being a normal term, because x is actually going to be a decimal here. 2 to the power of 1, this is equal to 2, and 2 to the power of 2, this is equal to 4, 2 to the power of 3, this is equal to 8. So 5 is somewhere between 4 and 8, so the value of x is going to be somewhere in between 2 and 3, and it's going to be a decimal. So now by using this property, I can move x to the front, and then now I can find the real value of x, the exact value I mean. So I had log 2 to the power of x is equal to log 5. Now by using this property, I can move x to the front, so now I have x times log 2 is equal to log 5. Now, if I divide both sides by log 2, these two cancel out, and I am left with x is equal to log 5 over log 2. Now, the value of log 5, this is equal to 0.6990. And the value of log 2, this is equal to 0.301. So now I have x is equal to 0.6990 over 0.301. And if I divide these two, I get x is equal to 2.32. So this is my answer. Alright, so I have 2 plus 2 is equal to 5. So let's first start with 0 is equal to 0. This is a true statement, right? 0 is equal to 0 because any number is equal to itself. So on my left-hand side here, I'm going to rewrite 0 as 20 minus 20. And 20 minus 20 is 0. So this is right. I'm not doing anything that is illegal here. And for my right-hand side, I'm going to rewrite 0 as 25 minus 25, which is also equal to 0. So I'm not going out of the rules or anything. Now, 20, this is the same thing as 4 times 5. So now I have 4 times 5 minus 4 times 5 is equal to 25. This is 5 times 5 minus 5 times 5. So again, I'm not going past the rules or anything. 20 is equal to 4 times 5, so I simply substitute in 4 times 5 for 20, and same thing with 25. 25 is equal to 5 times 5, so I simply substitute in 5 times 5 for 25. Now, this is the same thing as 4 times 5 minus 5. All I did was I factored out 4 from this because both terms were being multiplied by 4. And now this is the same thing as 5 times 5 minus 5. All I did was I factored out 5 from this because 5 is being multiplied by both terms. So now what I'm going to do is I'm going to divide both sides by 5 minus 5. So then these two cancel out and these two cancel out. And now I'm left with 4 is equal to 5. Now 4, this is the same thing as 2 plus 2. So I have 2 plus 2 is equal to 5. And there it is. I just proved that 2 plus 2 equals 5. However, this is actually wrong. And somewhere in solving this, I actually made a mistake that you cannot do in mathematics. So as you can see here, I had 4 times 5 minus 5 is equal to 5 times 5 minus 5. Now, 5 minus 5, this is actually equal to 0. So now I have 4 times 0 is equal to 5 times 0. And what I did was I divided by 5 minus 5 on both sides. And if you guys already didn't know, dividing by 0 is not defined, because anything divided by 0, well, as you see, 4 divided by 0, if we tried to do this, 0 times what equals 4? Well, nothing, because you can't multiply anything by 0 to get 4. 0 times anything is 0. So dividing anything by 0 is undefined. So when I divided both sides by 5 minus 5, I really divided both sides by 0. And now 4 times 0, so now if we do this, 4 times 0 divided by 0, this is 0 over 0 is equal to 0 over 0, and 0 divided by 0 is undefined. So this, you can't do this. So why dividing by 0 it can lead to weird results. Alright, so in this problem, I have 2 to the power of 10 plus 2 to the power of 10 is equal to 2 to the power of x. So I want to find the value of x here. So for my solution, I'm going to first start by rewriting my equation. So my equation is 2 to the power of 10 plus 2 to the power of 10 is equal to 2 to the power of x. Now, to solve this, what I'm going to do is first factor out 2 to the power of 10 from my left-hand side. So if I factor out 2 to the power of 10, I get 2 to the power of 10 times, well, 2 to the power of 10 divided by 2 to the power of 10 is 1, so I get 2 to the power of 10 times 1 plus 1 is equal to 2 to the power of x. Now from here, 1 plus 1 is equal to 2, so I get 2 to the power of 10 times 2 is equal to 2 to the power of x. And a simpler way of doing this is, instead of just factoring this out, well, we have two to the power of 10s here, and if anything added by itself is the same thing as that number times 2. So we could have just said 2 to the power of 10 times 2 at the beginning instead of factoring it out. So now from here, what I want to do is I can actually solve this from here in two methods. So for method 1, I have 2 to the power of 10 times 2 is equal to 2 to the power of x. What I'm going to do is I'm going to rewrite 2 as 2 to the power of 1. And now if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So in this case, 2 to the power of 10 times 2 to the power of 1 is equal to 2 to the power of 10 plus 1, which is equal to 2 to the power of 11. So I get 2 to the power of 11 is equal to 2 to the power of x, and if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, x is equal to 11. Now, method 2 of solving the problem from this step right here, so I have 2 to the power of 10 times 2 is equal to 2 to the power of x. Now, instead of multiplying 2, I'm going to divide 2 on both sides. So then these two cancel out, and I get 2 to the power of 10 is equal to 2 to the power of x over 2. Now 2 is the same thing as 2 to the power of 1. And if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 2 to the power of x over 2 to the power of 1, that's going to equal 2 to the power of x minus 1. And now, again, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 10 is equal to x minus 1, or I could write this as x minus 1 is equal to 10. And now if I add 1 on both sides, these two cancel out, and I get x is equal to 10 plus 1, which is 11. So as you can see, these are the two methods, and method 1 is actually much simpler. It only took a couple of steps compared to method 2. And now the final step that we have to do, and we always have to do this in every equation, is to check our answer. So our equation was 2 to the power of 10 plus 2 to the power of 10 is equal to 2 to the power of x. We got x equals 11, so I get 2 to the power of 10 plus 2 to the power of 10 is equal to 2 to the power of 11. 2 to the power of 10 plus 2 to the power of 10 is the same thing as 2 times 2 to the power of 10. And 2 to the power of 1 times 2 to the power of 10 is the same thing as 2 to the power of 1 plus 10, which is equal to 2 to the power of 11.